This is more for block 6, you individuals that are not here. Sorry, you are here, I'm not here. Let me go over some of the questions that the individuals in block 4 wanted to go over, which as you can see on the right is plenty of them, 4, 5, 6, 7, 10, 11, 12, and 13. I'm going to go over those questions so you can see them. The first one I want to go over is question number 4, which is right here. There's a couple ways that you can do these problems. You can do the double distributive property, you can do the the vertical method, which is above each other, or you can do a table. Who asked for number 4? Okay. With number 4, which method did you try? Double distributive property. So what I would do is I would whoosh, 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 and I would whoosh, whoosh, whoosh. What often happens when students get this wrong is they'll make a mistake with a sign or they'll make a mistake with an exponent. Those are the only really 2 ways to make a mistake. B times b squared is b cubed. B times a negative b is a negative b squared. So b times b is b squared, and that's negative. B times 1 is just a b. Negative 3 times b squared is a negative 3b squared. Negative 3 times a negative b, and negative times negative is a positive 3b, and negative 3 times 1 is a negative 3. So now I combine my like terms. There's nothing else to match up with b cubed, so it's b cubed. I have a negative b squared and a negative 3b squared, that's a negative 4b squared. I have a b, and a 3b is a 4b, and a negative 3 is my constant at the end. So this is a 4-term polynomial of degree 3 with leading coefficient of 1. The next question I'm going to go over is number 5, which is over here. Who asked for number 5? So, which method did you use? The Punnett square method, the table method. Which one did you put on the side? Did you put s plus 4 on the side, or did you put s plus 4 on the top?
S plus 4 on the top.
Okay, some of you on the side, not that it really matters, but s and 4, and then this one is s squared, 6s, and a negative 5. Doesn't really matter. We end up with the same 6 term either way. S times s squared is s cubed. S times 6s is 6s squared. 5 times negative s times negative 5 is negative 5s. 4 times s squared is 4s squared. 4 times 6s is 24s. And 4 times negative 5 is negative 20. What you'll often find is that the like terms are on diagonals of each other. So if you did not get like terms on diagonals, you probably did something wrong with your multiplication of your exponents. It's s cubed plus 10s squared, because they're both positive. These 2 fight, plus 19s, and then a negative 20. Again, this is a 4-term polynomial of degree 3 with leading coefficient of 1. Number 6 is the next one. I'll do the horizontal method. And I'll do the table method because that's more realistic for what you guys are probably going to do. I'll do it this way this time. Negative r and 7, and this one is 2r squared, a negative r, and a negative 9. Negative r times 2r squared is negative 2r cubed. Negative r times negative r is a positive r squared. R times r is r squared. Negative r times negative 9 is a positive 9r. 2r squared times 7 is 14r squared. If you notice, again, these are on a diagonal. Negative r times 7 is negative 7r. Again, these are on a diagonal. Negative 9 times 7 is negative 63. Like terms are on the diagonal, not a coincidence. Be careful with your circling. As I just did, you might forget that negative is there. So you got to be careful with those negatives. It's negative 2r cubed plus 15r squared. Yes, 1 and 14 is 15. Plus 2r minus 63. Is a polynomial of 4 terms, degree 3 with leading coefficient negative 2. Number 7 is slightly different because it requires you to follow order of operations and you're going to add at the end. This one said, well, there's a multiplication here and a multiplication here. This multiplication is pretty easy. It's just the distributive property, whoosh, whoosh. P times 2p is 2p squared, and p times negative 3 is negative 3p. Plus, let's figure out what this is. I'll again do the double distributive property, whoosh, whoosh, and then whoosh, whoosh. P times p is p squared. P times 3 is plus 3p. Negative 3 times p is a negative 3p, and negative 3 times 3 is negative 9. Now these are additive inverses, so they cancel. I can get rid of that right away. That's pretty nice. I can deal with the rest. All right, I got a p squared and a 2p squared is 3p squared. There's only one negative 3p, and there's only one constant negative 9. There's a trinomial of degree 2 with leading coefficient of 3. Moving on to number 10, essentially the only division problem that was on here. It's more complicated when you see it like this. It's less complicated if we write it like this. 9m to the 5th minus 6m cubed plus 12m squared, all divided by 3m. When you write it as a fraction, which is still division, it's a little bit easier to see. Each of these terms is going to get divided by 3m at its own pace. Because one of the things we're allowed to do with fractions is we're allowed to split this. 9m to the 5th over 3m minus 6m cubed over, this is just adding fractions, you keep the same denominator. Plus 12m squared divided by 3m. I mean, you could do this step that I'm about to do. You don't have to, because it's really just dividing each of them individually. You could just divide this. But if this makes you feel better, do this. 9 divided by 3, that's 3. M to the 5th over m, there's more m's on top by 4. 6 divided by 3, negative 2. There are more m's on top by 2. 3 minus 1. 12 divided by 3 is 4. There are more m's on top by 1. And this is the trinomial of degree 4 with leading coefficient 3. You could have just divided. It would have been the same thing, but if you feel like splitting it, it also will work. I was just told that on the answer key, this was 3m cubed, which obviously means that the answer key is wrong. Hopefully everyone in this class already fixed it, so you guys in block 6 would have no idea that it was 3m to the 3rd, it was 3m to the 4th, but that's what the answer should have been. Number 11, you might be tempted to say, oh, I'll distribute the 2, which is wrong. That does not happen. We do not distribute the 2. That's, for lack of a better word, distribute. We do that when it's one term. This is a binomial, not a monomial, so you cannot do this. This is 2r plus 9 s's. So you need to set it up as 2 binomials, and then we can double distribute. And now that we've made it 2 binomials, we double distribute, whoosh, whoosh, r times r is r squared, r times 9s is 9rs, and we'll put them in alphabetical order. So that way I know that they're like terms, because then I'll do 9 times s times r is again 9rs, putting in alphabetical order so I can clearly see that they're like terms. 9s times 9s is 81s squared, because 9 times 9 is 81, s times s is s squared. Those are my like terms. R squared plus 18r s plus 81s squared. Trinomial degree 2. Question is, which is the leading coefficient? Hard to tell because you might want to say r. If we're going to say 1, because that's alphabetized. And the mistake for number 12 would essentially be the same. This is not, for lack of a better word, distributing. Again, it's 6x plus 5 times the other 6x plus 5. Not actually going to do that, so I think you guys see the mistake. Again, you have to double distribute both sides, or you have to set up your table. It's not just simply 36x squared plus 25. It's more complicated than that. Move on to the last one that I'm sure we all want, which is number 13. Actual Punnett squares. In P plants, the gene capital G is for green pods, and the gene lowercase y is for yellow pods. Any gene combination with a capital G results in a green pod. That's called a dominant allele. Suppose 2 pea plants have the same genetic combination, GY. The Punnett square shows the possible gene combination of an offspring pea plant and the resulting pod color. What percentage of a possible gene combination of the offspring plant results in a yellow pod? I think that should be pretty obvious. Out of the 4, there's 4 possible outcomes. Out of those 4, how many are yellow? 1 out of 4, which is probability. If we want to do the ratio would be 1 to 3 of yellow to green. 1 yellow to 3 green. If we want to do the probability, the possibility, that's 1 out of 4, 25%. That's probably the trickier one. Part B is the trickier one. Let's do that. Essentially what it's saying is there's 2 things that we're getting our genetic makeup from. We're getting it from one of them and the other one. Now the one of them has a 0.5% chance of being G and a 0.5 chance of being lowercase y. Same thing would be here. It has a 0.5% chance of being G and a 0.5% chance of being lowercase y. That's where those numbers came from, a 50% chance of being capital, 50% chance of being Y. So we have it, half of them we're gonna get G's, and half of them we're gonna get Y's, and it works for both of them. Well, let's see how that plays out with actual mathematics. 0.5 G times 0.5 G is 0.25 G times G, or G squared, capital G squared. This one is 0.5 times 0.5 G times Y, so it's 0.25 GY, alphabetically. This one, 0.5 times 0.5 G, is a 0.25 capital G lowercase y, putting them in alphabetical order. And the last one is 0.25 YY. Combining my like terms in the middle, that's a 0.25 GG. In other words, there's a 25% chance you're both capital G's, both dominant. There is a 0.5 or 50% chance that you are hybrid or both. And there's a 0.25 chance that you're YY, or 25% chance. Both recessive. So that's how we can use the math with the percentages and the probabilities to figure that out.